You ever see the documentation for a big API, like a really big one, and just wonder, could I actually build this from scratch? Well, today we're going to follow a developer who did just that. And trust me, what they found was way messier than the clean docs would have you believe.
And that's the big question, right? How do you actually clone a production API when all you have is the public manual? It's not just about writing code. It's like being a detective, piecing together clues and making some serious engineering calls along the way.
Yeah, forget the perfect textbook examples. We are diving headfirst into the real deal here. We're talking about the weird, the confusing, and yeah, even the brilliant design choices you only find out in the wild. This is all about what it takes to rebuild a living, breathing system from the ground up. Okay, so right out of the gate, the first major roadblock wasn't some cool feature. Nope, it was security. And not your standard run-of-the-mill security either. This thing was, well, it was weird. It felt like it broke every rule in the book. So check this out. Pretty much every modern API you'll ever work with uses one standard thing for security, the authorization header. It's the way it's done. But this API throws that right out the window. Instead, it demands two totally custom headers, one called token and another called xClient source. I mean, right away, you know you're in for a ride. And this right here, this is so real for so many developers. You don't always get shiny, new, perfect systems. A lot of the time, you're dealing with these strange legacy decisions, and you're left thinking, why on earth did they do it this way? But you know what? It doesn't matter. Your job isn't to judge it. Your job is to replicate it. So what's the solution? You can't use the standard tools, so you have to build your own. You essentially create a custom security bouncer for the API. In the tech world, we call this a custom authentication handler. And its job is simple. It stands at the door, and it stops every single request to check its ID, in this case, those two weird headers, before it even thinks about letting it in. And this bouncer is thorough. It's got a two-step checklist. Step 1, check that xClient source header. That tells it who is knocking at the door. Step 2, it looks at the token. Now, this token is a JWT, a JSON Web Token, which is basically a fancy secure digital ID card. It tells the bouncer what this person is allowed to do once they're inside. If and only if both of those things check out, then the request gets to pass.
All right, so we've got our bouncer, and it can read the client ID. Awesome. But that just leads to the next problem, right? How does the bouncer know that the ID it's looking at is even real? Where's the official guest list? What's the source of truth here? And this, my friends, is a classic problem in software architecture. You need to check if something's legit, but where do you go to check? As you're about to see, the developer's first instinct, well, it wasn't the final answer. Not by a long shot. Watching the solution evolve is really the cool part. Attempt number 1 was, let's be honest, a hack. A simple if statement. It's fast, sure, but it's brittle and completely inflexible. So attempt 2 was a bit better. Just ask the database directly. That works. But now your API is stuck, it's tightly coupled to that one specific database, and that brings us to the final solution, a dedicated microservice, a whole separate, specialized service whose only job is to answer one question. Is this client ID valid? It's clean. It's separate. It's built to last. And what this unlocks is a super important architectural pattern called database per service. The idea is actually pretty simple, but it's so powerful. Each little microservice is the king of its own castle, and that includes its own private database. The main API doesn't know how the authentication service stores its data, and frankly, it doesn't care. And that separation is the secret sauce to building systems that don't break easily. Okay, so with security finally sorted out, and that was a whole adventure in itself, it was time to get to the main event, building the actual business logic. You know, the stuff the API is supposed to do, like letting a user create an order. But just because we're on the fun part doesn't mean we can't get sloppy. The goal is always to avoid a tangled mess of code. So, to keep things clean, the developer used another classic design pattern, the repository pattern. You can think of it like a professional middleman. Your main business logic never talks directly to the database. That's messy. Instead, it just talks to the repository, and the repository handles all the nitty-gritty details of getting the data. And this breakdown shows you just how clean that is. Up top, you've got the API controller, just handling the web request. It talks to something called a repository interface, which is just a contract that says what we need to do, like create an order. It doesn't care how. Then you have a totally separate implementation that says, okay, here's how we create an order using MongoDB.
The real magic here, if you decide to switch to a different database tomorrow, you just swap out that one implementation piece. The rest of your code doesn't even notice. That's flexibility. All right, so we've been on quite the journey here. We've cracked custom security, we've watched a simple idea evolve into a full-blown microservice, and we've built the business logic in a super clean way. So, what are the big lessons we can pull from this whole quest? It really comes down to 3 key patterns that are worth remembering. 1, custom authentication handlers. They're your secret weapon for dealing with weird, non-standard security. 2, microservices and the database per service pattern. This is your ticket to building systems that can grow without collapsing on themselves. And 3, the repository pattern. It's the ultimate way to keep your core logic clean and separate from your data. And that brings us to the final big idea. That whole evolution from a simple if statement all the way to a microservice, it might look like overkill at first. But so often the design choice that seems overly complex today is the very thing that saves you and allows you to scale tomorrow. And it's a great question to ask yourself, what trade-offs are you making in your own projects right now? Are you building for today or for tomorrow?